Introductions. Electricity and magnetism drive progress in electrical transportation, including electric cars and trains. The field has evolved historically, showcasing cutting-edge advancement and promising future innovation. Appreciating its significance requires understanding the context, current technologies, and potential future developments. So let's get to know the significance of electricity and magnetism in electrical transportation. The first significance is powering electric vehicles. Electricity is the primary energy source for electric vehicles (EV). It allows for cleaner and more sustainable transportation by replacing traditional fossil fuel-based engines with electric motors. Next, efficient energy conversions. The interplay between electricity and magnetism enables efficient energy conversion in electric transportation. Electric motor convert electrical energy into mechanical energy, providing a highly efficient and responsive means of propulsion for vehicles. The next significant is innovative technologies and sustainability. Electricity and magnetism advancement drive innovative technology in sustainable electrical transportation. Electric vehicles cut emissions, reduce fossil fuels dependence, and promotes renewable energy aligning with global climate effort.
Relevant electricity and magnetism concepts. What is electricity? Electricity being described as either static or dynamic. When electricity is static, first, electrons are rest. Second, occur when non-conductive materials rub together and cause transfer of electrons. Third, no current flowing in AC or DC electricity. Next, what is magnetism? Magnetism refers to the force which the magnets exert when they attract or repel each other. Components involved in electricity and magnetism concepts about electric car are inverter and electric traction motor. Inverters. First, electric vehicle inverters change the battery pack flow of electrons from a DC to an AC. Next, inverters are necessary components for EVs because lithium-ion battery can only accept DC power, and electric traction motors require AC power to function. And lastly, inverter used to control the frequency of the AC power being sent to the motor, so they play a direct role in controlling on EV speed.
The old trick to making our magnets spin, which is essentially how electric motors work, is through the so-called inverter. The inverter module on the EV draws direct current from the car battery and, through a clever combination of quick switches, slick circuitry and capacitors, flips the flow of electrons back and forth nearly 60 times a second. Domestic electric motors, like the one you have in your hairdryer, don't require an inverter. Why? Because the current that comes from your wall outlet already flips back and forth. That's why it's named alternating current, or AC. Batteries of any type can only ever produce DC, or direct current. So, spinning magnets driven by alternating current passing through coils of wire is essentially what drives electric cars.
Electric traction motor. Receiving electricity from the inverter, the electric traction motor provides the power that makes an electric vehicle move. Next, electric traction motors are commonly powered by an AC. Lastly, when AC electrons switch the motor via the inverter, they generate a rotating magnetic field that causes the motor to turn.
Another nifty detail about any EV's powertrain is when the shaft-mounted magnet, or rotor in engineering parlance, is itself spun, it generates electricity. This reversal very handily recharges the car battery. How can the rotor be turned, you ask? With any hefty source of kinetic energy, like, say, a braking automobile, which is handy. This is, to be clear, a very simple overview. There's different types of electric motor, and refinements to the design are happening all the time. Not least at one particular Californian car company named for the 19th century genius who discovered the magic of alternating current by himself, Nikola Tesla.
Exploration of electric car. The first thing is battery technology. As we all know, the heart of electric car lies in their batteries. Electric cars commonly rely on lithium-ion batteries for their high energy density, efficiency, and lightweight design, featuring a battery management system (BMS) to monitor and optimize cell performance along with the thermal management to prevent overheating and ensure overall efficiency. Next, Safety system. Electric vehicles implement rigorous safety measures such as thermal management and cell level monitoring for battery safety, coupled with the dedicated crash protection structure to safeguard both occupants and the battery during collisions. The last thing is autonomous driving. Certain electric cars incorporate sensors and cameras to enable advanced driver assistance system (ADAS) and in some instances, autonomous driving functionalities.
Potential benefits of electric car. A. Environment benefits. They are much cleaner and greener than traditional gas-powered car. Significantly, fewer greenhouse gases, which can help reduce the carbon footprint of drivers. B. Performance and efficiency. Electrical vehicles have a high performance rating and are known for their efficient driving capabilities. Electrical vehicles have a regenerative braking system that captures energy during braking, which can extend the vehicle's range and improve fuel efficiency. C. Noise pollution reduction. Electrical vehicles produce significantly less noise pollution than traditional gas-powered car. The lack of engine noise makes a quieter and more peaceful driving experience, especially in urban areas.
Listen, it's just a very quiet electric vehicle. See? Very, very quiet. But if you switch this up to largest change, listen to this. Tell me that doesn't sound awesome. And not only that, you can change what it sounds like. So if you go to custom settings here, and you can choose 3 different ones. You can choose stylish, and then there's also dynamic, but by far the funniest one is the cyber. Provides a new futuristic electronic sound for electric vehicles.
Challenge of electric car. A. Range anxiety. Electrical vehicles have a limited range and requires charging station to refuel. The availability of charging station varies widely, and some areas have limited and no charging infrastructure. B. Charging time. The time it takes to charge an electrical vehicle is longer than the time it takes to fill a gas tank. Even fast charging station takes about 30 minutes to charge a 80% capacity. This makes charging an electrical vehicle a more significant time commitment than fueling a gas-powered car. C. Upfront costs. Electrical vehicles are generally more expensive to purchase than gas-powered cars. This can make them less accessible to a broader range of consumers. However, the total cost of ownership of an electrical vehicle is generally lower due to reduced operating costs and maintenance.
Future developments and innovations. Number 1. Solid-state batteries. First, promise higher energy density, faster charging and improved safety. Second, potential to revolutionize electric vehicle range and performance. Number 2. Autonomous driving technology. First, advancement aim to enhance safety and efficiency in electric transportation system. Second, it could transform the driving experience and potentially reduce traffic issues. Number 3. Ultra-fast charging infrastructure. First, advancement in 800-volt systems and high-power charging station
enable rapid charging. Second, developing efficient wireless charging solution for convenient recharging options. So, for the conclusion, we state that the application of electricity and magnetism in electrical transportation, particularly in electric cars, represent a transformative force in the automotive industry. This shift not only offers a cleaner and more sustainable mode of transportation, but also stimulates technological advancement with broad societal and economic implications. As research and development continue, the integration of electricity and magnetism in transportation is poised to play a central role in shaping a more sustainable and technologically advanced future.